When you talk to your colleagues, are you a radical?
I think
I'm Stuart Muir. Welcome to Power Struggle. Today on Power Struggle, we're joined by Valentina Riggins, a visionary leader in the digital energy space and the Senior Vice President of Consulting Digital at Worley. With a career spanning continents from Europe to Canada to the Middle East, Valentina has transformed digital divisions into profit powerhouses. She's spearheaded innovative partnerships and driven AI-forward solutions for sustainable energy. Whether it's the energy trilemma, the potential of AI, or the challenges of making renewable assets truly sustainable, Valentina is here to talk about the energy future she's helping to create. Valentina Riggins, welcome to Power Struggle.
Thank you, Stuart. It's great to see you again.
Yes, it is. Valentina, why don't we start at the beginning? What got you to where you are now?
Oh, a lot of struggle, I guess.
You're the perfect guest for Power Struggle.
How did I end up in an energy space? I think by a total luck, to be honest. I never thought I would get into energy industry. I had an IT degree and I decided to be entrepreneurial and leave my hometown and test my luck on the other side of Kazakhstan, 3-hour flight away, in hope that I will learn something. So I was lucky to meet some people from Schlumberger, which is a full services company. And I told them, look, can you just take me as an intern for 2 months? I just want to learn because in university I haven't learned anything that is useful. And I want to work in a real company. You don't even need to pay me. I just want to learn. And they allowed me to come. And, it was uphill from there.
That's just fascinating. Worley, the company you work for, is a global engineering firm. Can you tell me how it specializes?
Yeah, so Worley essentially is building industrial assets. So if you think about all assets that deliver our energy today, liquefied natural gas facilities, or assets that produce all of the products that we use in our day-to-day life, everything from computers to baskets to whatever is made out of plastic, and even pharmaceuticals, petrochemical plants, and mining assets that deliver metals for our electronics and all other industrial assets. So that's what the company essentially does.
So you started in Kazakhstan, then you went to Canada, but now you're in Dubai, and that's where you're talking to me today, right?
That's correct. I'm in Dubai right now. I had few more countries between Kazakhstan and Canada, but we'll go with that.
Big shift. When you think about the different energy landscapes and the places where you've spent time, I'm wondering, how did this journey you've been on shape your understanding of energy and also what you wanted to achieve through that in your own career and your own life?
Yeah, I think before I got into the energy business, I probably didn't have appreciation over energy per se. And most of us don't even think about energy because it's just there for us. It powers our houses. It's warm in the winter. Where I'm from, it's very, very cold, just like in Canada. So I never even thought about energy deficiency or where it's coming from. It's sort of like your own body. It just works. You don't think about it until something breaks, right? And so when you get into that business, you start to appreciate the technology and the sophistication it takes to create energy and create the products related to energy and the engineering power and ingenuity that is required to actually make it happen.
So what was the first career opportunity you had where this picture you've just drawn started to come into focus for you?
Yeah, so I think the first one was with Schlumberger, where I literally, as a young engineer, was thrown in an oil field to see how the oil was produced, right?
In
and
Kazakhstan.
I was helping in Kazakhstan, and I was helping that company to set up their data for them so that they can analyze, they could run their oil field better, they would understand their production, and they could manage the reservoir better. So from there, it was all about data, and it was really early steps in the industry at the time to really understand how to be more efficient in fossil fuel extraction, because before the production data was pretty much, it wasn't collected necessarily in a proper way. The reservoir management best practices weren't quite there. So it all started emerging over time. And the more we learned about what's underground, because you can't see what's underground, right? The more we learned, the more data we collected. The sophisticated tools started coming up, simulation tools, the artificial intelligence-based tools. And that was back in 2007, where people didn't even talk about artificial intelligence in industrial applications. So in the energy space, we were already looking at those tools.
So we're really standing on the shoulders of work that's been going on for decades in AI.
Yeah, I think maybe the core digital industries, of course, did their research before, but I think the industrial application in this kind of heavy industries really stemmed from oil and gas, I would say.
Mm-hmm. And where you've gone in your career, which I think will be the fascinating thing about this conversation on Power Struggle, where literally the struggle to adapt, evolve, and keep the benefits of energy in our lives is what this is all about. I think you've personally lived that journey in a very interesting way.
Yeah, I would say so. In Kazakhstan, the energy practices of clean energy or the conscious energy production wasn't quite there at the time. That was more than 20 years ago. Mm-hmm. But I've seen the evolution of how the companies really paid a lot of attention to safety, to cleaner operations, to make it actually better. But I also saw other side of the energy business, or fossil fuel business, specifically, is that when these companies were coming into the countries like Kazakhstan and others, they were building roads, they were building schools, they were doing a lot of things for the country. And I'm a perfect example of an individual who comes from a very modest background in a country that doesn't necessarily have that opportunity to be global or be educated or whatever. And I was the person that had that opportunity to get educated, to be transferred out, to learn, to understand how other countries work, other cultures work. So there is aspect of it is not just energy, it's really creating opportunities for people to better their lives.
I'm just fascinated by the challenges of engineering. Engineers are brought in to solve what are described as impossible or unsolvable problems. Have you encountered such problems that were thought to be unsolvable, and then you had to figure it out?
Well, that's an interesting one. I think if you ask people who lived in 60s and 70s that, you told them that you will be able to talk like you and I right now and see each other, they would think you're absolutely crazy, right? Back 50 years ago, you would think this problem is never solvable. And it's the same thing with extracting oil, for example, from underground, or building solar panels that are actually efficient, right? The original ones that came out, they weren't very efficient. Now we look at solar panels, and the cost of solar panel is cheaper now than the cost of gas. So with this continuous iteration and innovation and engineering, and actually saying, it's not impossible, I'm going to get it done. I know what I want to get to, and I'll find a way to get there. That's where the engineers are really good at.
Mm-hmm. When we were talking about you coming onto the show, we were throwing some ideas around, some topics, and I thought you had some great ones. Let's start with the first, the energy trilemma. That's balancing sustainability, affordability, reliability, the three corners of the triangle. And if we don't have all of those covered, that's the issue of the times. How do you see digital technologies having an impact on sustainability and energy transition?
Yeah, this is a great topic. I love this topic. This is one of my favorite, and this triangle is real. However, I do believe that sustainability, reliability, and affordability can coexist comfortably. And the key for it is much more rapid innovation than we are able to do right now. And the way we do innovation, it's an experimentation. It's coming up with something that has never been done before. But to accelerate the experimentation, you need to be able to simulate billions of different scenarios. And that's where digital technologies coming in, and specifically now with AI. I was doing a lecture at the Western University Ivy Business School just a few weeks ago. And I've asked the students, how many of you are gamers? How many of you are playing computer games? And few raised their hands, like Boulder Gate or Witcher or whatever. And computer games are essentially simulations of the reality that create different scenarios of how things can go. But they're not just some simulation that is abstract. They have physics model behind them, because when you look at them, the water movements, the air, the trees, the hair, the facial expressions, it's all based on physics models. And AI just accelerate the different scenarios and models. Something like this needs to happen in the industry as well. And it is happening. I think it's not happening fast enough for us to create those sustainable sources of energy that are dense enough to power a lot of cities or power industrial assets, and that are clean at the same time. We just haven't really yet got to a point where we have enough data, and that's where the industry players all need to come together and share information with each other and work together to create those simulation models for the good of the society.
So the solution is not ready, and you're postulating the step that must occur for that to happen.
Yes.
And that step is we need to start modeling. I presume that's with the power of AI to speed up the generation of that understanding.
It's not just AI, it's really different ways of working and different way of collaborating between different industrial players within the energy industry. Today, the common struggle is that everything is seen as competition, and I'm not going to share, and I'm not going to work with you because that's my information and that's your information, and I'm not sharing with you. So this model, if we truly want to get to that sustainable energy, is going to prevent us from getting there, for sure.
Mm-hmm. So part of the problem is competitors guarding their intellectual property from others. But here we are in a free market system that is reliant on companies being able to get better at competing against each other. So it's kind of a dynamic tension between having the tools and having access to them.
And it's a tough thing to solve, right? But I think industry, the energy industry as a whole, really need to come together and decide what they're going to compete on and what they will not compete on. And I think getting to that cheap, sustainable energy is the area where there shouldn't be any competition, because that impacts everybody's kids, the whole society. I don't think it's right to compete on that.
That's an intriguing prospect, that maybe there are some inventions that should be put into the public domain right away so that we can have the level and pace of change that the world wants. Is there one thing that this approach could be applied to that, say, in 2 years, something that's impossible today, took that approach and it could be changed?
I would say nuclear.
Really? Why?
Because it's the most dense energy source existing today, and the cleanest one of all, in a sense that disposing nuclear waste requires putting it back on Earth, which is nuclear by nature, right? And so the technology is already there, especially with small nuclear reactors. But of course, we need to be mindful of water that is used in that technology and have ability to decontaminate the water that's coming out of it. But ultimately, this is the most dense energy source that we can use, and the cleanest one, and that does not really require a massive new infrastructure other than better grid capability.
I'm certain there will be someone listening who's going to say, please, can't you make the moonshot renewables? Do that impossible in a couple of years. What's your answer to that?
Right. So I'm an engineer, so I'll go into the engineering to explain the renewables. So what do we use to create renewables? So let's say solar panels. We use metals that are extracted out of the mining industry and plastics that are coming out from petrochemicals to build a solar panel. Unfortunately, some of those metals that are used in the production are toxic metals, and in their production, we're contaminating water. And then we have to look at the solar panel as well as wind turbines throughout the entire asset life cycle, meaning it's not enough just to build it. You also need to think about how you're going to operate it and maintain it. And more importantly, what happens at the end of life? What are you going to do with it? How are you going to recycle it? You also need to think about how much space does the thing take? Because our land is finite, right? We cannot put fields and fields of solar panels without disturbing the ecosystem that's in that space. So if you think about UAE or like countries like you say, oh, it's a desert. Well, desert is a massive ecosystem with a lot of animals living there, with a lot of creatures. So the fact that we're not disturbing humans doesn't mean that we're not disturbing everybody else. So we got to be very mindful in our approach in terms of what are we doing with the land, right? And how we're impacting living creatures there. Similarly with wind turbines, they're built out of metal and plastic and different materials that come out of mining and oil and gas, all the same problems. And they also take a lot of space. I was just reading an article about this new gigantic wind turbine that's creating a microclimate because it's so huge, like it's disturbing wind patterns. So when we build those things, we need to be mindful of how that new system that you have created, you're disrupting natural system. So that how does this new system that you have created is going to now operate, and what's the impact? And I don't believe that we've done enough studies in that, just because we don't know, not because people want to be malicious, but I think we don't know what we don't know. But I do believe is when we talk clean energy or renewables, we have to look at where is this thing coming from? How is it actually built, right? What does it take to build one? What does it take to recycle it when it's dead? That mindfulness is very, very important.
In 2023, when I visited Dubai and went out to where COP28, the climate summit, was being held, I literally, and everyone who went to COP28 literally drives past or takes the train past the world's biggest natural gas generation plant. There it is by the side of the highway. And I think lots of people were asking, because it was on social media, why, with all of this desert, why don't they have solar here?
Yeah, so for first production of the solar panels, again, toxic metals, really, like if they're not produced in the UAE per se, they're produced somewhere else. So you're using fresh water somewhere else to actually extract the metals and put it in. So what happens with the water? And then the solar panels here, for example, yeah, it's desert. It's 365 days of sun. There's hardly any rain ever, but there's sand and dust.
Right.
So every time the wind blows, or even if it doesn't blow, there's dust in the air because it's a desert. And so that dust precipitates on a solar panel, and you have to clean it very, very often, otherwise the efficiency drops. I actually wanted to install solar panels here for my house, but this was the biggest consideration. Well, I have to clean it every week, get on the roof and get it cleaned. Right. Like who's gonna do it?
So we have this shared goal of decarbonization, but different paths to get there. You've said that nuclear is the quickest way to get there, and you've spoken about AI. So I want to go back to that and figure out how that comes into it. I guess the first question is, what are the challenges in a rapid decarbonization model that AI can help?
Yeah. So one big one is really innovation and simulation of the whole ecosystem. So let's say we decided that the whole world moves to nuclear. Now, to be sure and to be comfortable with that decision, we need to simulate multiple scenarios of how it can go and how it can go wrong, right?
Right.
And so this is where AI, and that's why I bring in gaming, because now with generative AI, you can simulate conversational scenarios and you can put human in the loop. So before, the simulation engines would just do process simulation or mechanical simulation of an asset. But now you can simulate the real life. with AI. You can think about how supply chain is going to work, how the humans may or may not impact. Somebody goes and twists something and it blows up. So this is the kind of stuff that we can simulate. And by simulating that, we can understand what the risks are much better and create the assets that are much better and don't allow for the mistake at all, that they don't create a room for a human to go and mess something up. That's where we need to get to.
Valentina, for anyone who's listening, who's the parent of a teenager who maybe is in their bedroom right now playing video games, I think you just told us that gamers can save the world.
Well, I didn't say gamers per se. Unless gamers decide and get engineering degrees and go for industry and apply the knowledge of gaming, I think it's going to be challenging for them to save the world. But I think
there's a step there.
Yeah, gaming technology and where it got to by blending AI and physics models, that's going to be a game changer.
It's so relatable when you talk about gaming in this sense. What's an example?
Yeah, so if you think about games like Baldur's Gate or the other ones, and actually there are games now that are used in kids' education for them to learn history, right? Because the games are so accurate in terms of historical representation of the characters and how they would speak and whatnot, because they're trained on those big, large language models. And also from the physics and Earth view perspective, it's super, super realistic, right? So the games combine the best of technology. The games combine the simulation, which is physics-based simulation for water, for air, for movement of trees, hair, all of that. And now with the new generative AI capabilities, previously it would be just a dialogue that was pre-programmed. And you had a choice. You talk to a game character, and you pick an action with the character, and then the game flows in a certain direction. So all of this was pre-programmed. So somebody actually thought through. If you remember early games that came in books, right? So it's kind of, and you had to read and create an answer and go to the page, and it will tell you what's going to happen.
I remember playing Dungeons and Dragons on my Wang microcomputer in an international organization. I don't know if the bosses knew we were using these sophisticated machines for that, but it was early days.
Yeah, but the principle is a computer science principle. It's a what if scenario and if then operator. So if you said this, then the next step is that, right? So now with generative AI, what is generative AI? It predicts the next word. That's what it does. Out of trillions of terabytes of data, right? So it predicts the next word. So now you give AI a choice, but it's not prescribed anymore. So NVIDIA actually released just recently a game that's fully enabled by generative AI. And it's conversational, and the flow of the game is controlled by AI now. And that's where technology got it. It's no longer prescribed. It actually innovates or creates and generates a different result on the fly.
Well, imagine kids who are fascinated by gaming could think of themselves as having a place in the future. And one of the challenges right now I hear from people in academia is that there's a waning interest in engineering as a course of study, and therefore there's going to be fewer engineers out there accredited in the world at a time when we need them more than ever. So do you think there's potential here for, that connection to be made?
I think there is, and I think we do need to make a connection. My personal opinion, we need more engineers. We need more engineers, more mechanical, more electrical, more people that really understands ins and outs how things work, but not just engineers. We need unicorns. And by unicorns, I mean people who have this core engineering degree, but they also have digital degree. They understand the data. They understand how to architect it. They understand how to build data science models. So this blended skill set is absolutely critical for the type of innovation that we need to get to.
So making the connection between solving energy challenges using these principles and tools, how would we do that?
What we're missing is enough computing power, enough power to simulate thousands of different scenarios, or maybe millions of different scenarios right now. So usually when we use just a simulation engine, and I can going back to my oil and gas past, I used to model oil wells. And I had a simulation engine that would incorporate fluid dynamics into it and some mechanical properties of how the well is built. And what I wanted to predict is what the flow rate of the well is going to be. Am I going to have any production problems? Am I going to have a buildup of wax or whatever that is? And am I gonna get the rate that I need to get in order to fulfill my obligations with the oil? And is the properties of the oil right thing? So we use the simulation engines for that. But to run those models back in the days, one run takes you 2 minutes, but you need thousands of them. So you spend a lot of time changing the conditions and understanding how the well would work. If you upscale it to energy assets, similarly, you want to simulate asset performance before you build it. And you want to simulate bazillion of different scenarios, right, of how it could work. So today there are simulation tools that can do the process simulation, that can do the mechanical, fluid dynamics, all of that. But they cannot simulate how people will behave. And this is the big factor, right, in the performance and in how people maintain things. What are they going to do? So if we're assuming that the asset is manned, we need to be able to simulate everything, the whole ecosystem, the entire system, right? That's where AI combination with the simulation model really comes in. And then it helps you decide, well, how many people do I actually need there? What are the typical mistakes that they can make? How would it go? And then combine it with this traditional engineering simulations. And you're going to have a much better understanding of your risks, because it's all about managing risk at the end of the day. And when you're prepared to manage risk, you know how to respond, right? And that increases your safety, productivity, and everything else that you need to improve.
Okay, suppose I'm an investor. What you said is exciting because I think I could make more money by being more efficient that way. How's it going to be more sustainable?
So the sustainability of the asset operation is one of the variables, right? So you need to find that golden middle of what your operating envelope is going to be to make sure that it's also sustainable, considering all of the different risks that are there and considering the entire system. So if you're an investor and you want to build, say, a hydrogen plant, you need to know how the whole thing is going to work, not just plant itself, but actually look at who's going to buy it, how am I going to supply it, how am I going to build the infrastructure, what's the commercial model going to look like, how the people will be interacting with each other. So you're creating a game, a simulation in the digital world before you actually build the physical thing.
Now, we've still got this gap you talked about. We have this cautious nature in industrial innovation today. We still have that. Valentina, how would you respond to critics who say this hesitancy is why energy transition is turning out to be so slow and so challenging?
Yeah, I think there's much more to play there than just hesitancy to innovation. There's conflicting interests. There's business model that doesn't facilitate collaboration. I think when it comes to new energy sources, I can give you the hydrogen example, for instance. From my understanding, we're producing the hydrogen the same way we were producing it for years, right? Hydrogen is not new. It was used in military for rocket fuel. And it's highly dense energy source and clean per se. But it comes with different challenges, everything from there's no supply chain set up for it and infrastructure and off-takers. And our whole world is designed for fossil fuels at the moment. So that transition is really, really hard. And there is a lot of uncertainty associated with it. So investors really don't actually want to take those projects on. But I think if we could simulate how the whole thing is going to work, the economics of it, what it's going to take to actually transition the vehicle, everything that we have into that kind of economy and make it safe for us, because hydrogen is also not this, it has its own challenges, right? It makes pipelines brittle, which may cause explosion. It's invisible when it burns, so explosion is a high risk. And so we need to find and come up with materials innovate materials that are not prone to problems. And then when you put it in your vehicle, then it's all the same issues, right? But I think that fundamentally, to convince investors to actually put their money into this new energy, you need to give them all of these realistic scenarios of what is going to happen so that they're comfortable that their money is not going to be wasted. And we haven't yet got to that point, I don't think.
Hydrogen is what everyone is talking about right now. Are you worried that if we don't solve these challenges, you talk about the physical challenges, there's probably some economic challenges too, but clearly, and you've also said this, it works. Hydrogen is a reliable rocket fuel because it works. You can translate that through a chemical reaction. You translate that molecule into energy exactly when you want to and how you want to with high density. All of these prerequisites for success in the energy struggle, it's got them, but it's got these negatives too. So I'm growing concerned that if the hype part of this grows faster than the reality of implementation and problem solving, then at some point there could be a mismatch there. And that leads to the trough of disillusionment. It's a classic characteristic of innovation, of course. What do you think we can do through the tools that you have, Valentina?
What we need to do is make it dirt cheap compared to gas and fossil fuels. And if you think about why did oil and then gas take off, right? It's because it was much cheaper and higher quality than what alternative that existed back in the days, which was biological oil, right, from whales and whatever. Oil was burning, it was smoking, it was poor lighting ability. So when kerosene came in, it was much cheaper, it didn't smoke, much better light came out of it. And of course, naturally, people would want that fuel. And the adoption happened organically, and the infrastructure was built organically. What we're doing now with hydrogen, we are forcing it down everybody's throat. Where we should be doing is innovating to make it cheap and safe. Then people will adopt it.
Let's pivot over to another part of our energy future. Renewables. You compare renewables to nuclear. Let's compare them to hydrogen.
Yeah, we can do that. So generally, when I look at it, I look at it from the value innovation perspective. What is value innovation? I touched on it a little bit. Value innovation is creating a product that is by far superior quality to what exists, right? And it's cheaper, essentially. And by doing that, you create a new market, typically, right? So that's what value innovation is. So when oil and gas came in, it was a true value innovation. The market didn't exist for it at the time, right? It was cheaper product, much better quality than animal oil, and therefore it replaced, and then many other things came out of it. Now, I don't know what else will come out of hydrogen other than energy, but let's just focus on my energy. So if we're comparing to what is today in the market, what are the challenges and problems that matter to people that this clean energy source needs to solve? Well, for one, it needs to address greenhouse gas emissions, right? We'll talk about it. We want to reduce it. Great. That's one problem. Two, we also have other problems that come from, say, mining and oil and gas and other industries as well, which is soil pollution, right? With heavy metals, with chemicals and other things. Then we've got water contamination. So greenhouse emissions is not the only problem we have. Right? But it comes from how industries are working right now. And then we got reliability. So how reliable this energy source is, what does it cost per kilowatt, and energy density. So meaning how much energy can be produced with the same amount of fuel, you can power a bigger city or a community or whatever that is. So these are the 6 key parameters that I would look at. And if you compare renewables to, say, hydrogen, and let's talk about the first one, addressing greenhouse emissions. Solar and wind don't actually necessarily address greenhouse emissions. They may address them as a scope 1 and 2 greenhouse emission. But if you think about how those things were produced, they were produced by using oil and gas and mining as a source material to create those. And unless your mine is completely green or your oil and gas facility is completely green, we can't say that solar is reducing greenhouse emission completely, right? It will reduce it where it sits, but everywhere else in the ecosystem, probably not. Then if we look at hydrogen, it depends on the hydrogen type. If we're talking blue hydrogen, same problem because it's produced out of natural gas. And green hydrogen, yes, but what we don't know is it creating problem then for waterways and ecosystem because we use water to produce it. So what happens with our consumption of water? So then soil pollution, solar and wind, absolutely no clean bodies by any means, because like I said, toxic metals and how we're producing and water and soil contamination go hand in hand with those technologies, unfortunately. With the blue and green hydrogen, it's a little bit better, but again, I think there's more investigation to be done there, right? If we're talking blue, for sure it's oil and gas source. If we're talking green, are we really doing favor to the waterways and water that we use? And then reliability of supply. Solar and wind are not reliable energy sources. They're highly dependent on the outside conditions that are not in our control. They will require batteries, which again, depending on how battery is done, there could be some issues with the soil and water and air pollution. For hydrogen, it's a reliable source. It works similarly to natural gas. However, there is no infrastructure for it right now, which is something that hopefully can be solved. And then finally, if we go to the costs of production, solar and wind are quite competitive now on cost with the evolution of technology, but the energy density is extremely low, very, very low. You cannot power a whole lot with those two.
Valentina, we're talking about the material inputs for humans to live the way we do in this modern world. People get energy kind of two ways. They get energy from electrons. You know, you plug in your phone and some electrons come down the wire and charge that battery, and then you've got a phone that works. That's electrons or electricity. And then people get energy from molecules. That's from, chemistry and the hydrogen or, long chain hydrocarbons that we call gasoline or diesel and kerosene, so you can fly around. Those are two things, but it seems like so many of the political and social and scientific challenges are around what's the future? Is it going to be molecules or is it going to be electrons? Let's talk about that.
Let's just step away a little bit from the energy, because the energy topic is very important, but I think the important topic as well is contamination, right? And sustainability doesn't mean we just do greenhouse emissions. Sustainability means we do no harm as a first to our environment and to ourselves, right? And I had a very interesting conversation that I ran one of the workshops, and I was asking people, okay, well, what is the asset of the future? What is industrial asset of the future? How do you see that, right? Yeah. And people were coming up with all kinds of ideas, and some of them were around, well, the asset of the future actually needs to improve the ecosystem and environment that it operates in, how the biodiversity and whatever. And the asset of the future needs to be self-healing, so we don't need to produce any more metal materials and valves and whatever to replace stuff. So we need to come up with materials out of which we build these industrial energy assets that are self-healing, and you don't need to maintain them, and that will drive the cost of energy down. And then they were talking about supply chain and how do you bring things, and talking about anti-gravity travel, right? And this seems like completely irrelevant. This is crazy stuff, never going to happen. But remember, we had this conversation. What is this crazy stuff that's never going to happen that engineers would figure out? And so that really speaks directly to quantum physics and the research in that space, the anti-gravity travel, the ability to have travel devices that actually are not bound to overcome resistance of gravity, right? That don't actually require that much energy. So this is all really fascinating stuff. And if you think of innovation where it needs to head, I think this gives you a bit of an idea of how we can get to that sustainable energy space.
Well, you've got goosebumps happening here, and you're portraying this future of energy. And I think what you're telling us is probably what you're also telling your clients as you are proposing how to figure out how to solve their problems, which are, these are colossal industrial projects that you're designing. Am I right? That will be
Yes.
around for 50 years or 100 years. You're doing that.
Well, it's a bit of a struggle, actually, and it boils down to the business model. So what I see, and this type of innovation is what is perceived by the industry as absolutely crazy stuff that will never happen, right? Or very,
Right.
very far away, not in our time, and we're going to happily retire. A lot of it is driven by the fact that a lot of these companies are publicly traded companies, and they respond to their shareholders, and they have to make their quota every time. They have to return the results and whatever. They don't actually have that whole lot of room for that kind of breakthrough innovation. It comes out of startups and privately owned companies who can make decisions to take their profit and pour it into R&D, right? Because they don't need to respond to the shareholders and convince the board or whatever. Not as much anyway as the publicly traded companies are. So this setup by design is not actually fostering innovation. Unfortunately, a lot of these companies have the data that is required for innovation like this, but they don't want to share it. So we have a bit of a struggle here.
Well, you are a juggernaut of change. You are in the most influential conversations in the world in the energy transition. How do we get the next generation of energy leaders to start to think like you, to make those big changes that industry's maybe not quite ready for in full?
We need more trailblazers, and we need to foster from the early age in kids the diversity of thought. We really need to teach our kids to think, not to give the answer. And this is the fundamental shift in what needs to happen in schools and in university. I think oftentimes in schools, we just give kids the answer and tell them this is the answer. We don't really teach them to critically think. And that's where it all starts.
And if I give the wrong answer, if I'm that student, then I get an F. So I got to make sure I just give the right answer that you told me before that I should give, and I'll get an A, and everything will be good. But that's not the way to go, you say.
No, I don't think that really works if you truly want to get ingenuity out of kids and foster that and get it to a certain level. I think there's some transformation required in our educational system.
Fascinating. You've worked with some pretty incredible global teams, and you've grown digital businesses. You've been part of a transformation that's been occurring for the whole scope of your career. What's the most surprising thing you've learned from leading people and teams in energy?
I don't think I realized it for the most of my career until I had kids. And I think all adults have their internal kid, and they're driven by two things. It's either fear or excitement. And you get somewhere when excitement overcomes the fear. And that's I think that's the biggest learning in the energy transition. If we find a way to overcome the fear of whatever the fear is with excitement for many, many people and create that critical mass, I think that monolith is going to move.
When you talk to your colleagues, are you a radical?
I think if you ask my colleagues, they would say that I'm visionary, trailblazer, absolutely crazy thinking person. So you could name it radical.
Hey, that's a compliment. What's a passion or interest you have? You've got this exciting career. It keeps you busy. You have teams all over the world that you work in. But outside of work, what keeps you balanced?
I was just thinking about it. What really is my passion? And my passion is helping other people, actually. At my core, coming from where I'm from and getting there didn't happen by chance. I was helped along the way many, many times by many, many people. I'm very much into biohacking. I'm very much into health and wellness and sports and things like that. That keeps me grounded. Just, get out in the morning, get the first sunlight, get just sit and stare at the fire when I have an opportunity, or just walk around bare feet on the ground and appreciate things that I have. Because where I am right now, I think it's only upside from where I came from, right? So I'm at a point in my life where I can give more to others as well. And that's what my passion right now is.
Valentina Riggins, thanks so much for spending time with me and the Power Struggle audience today.
Thank you, Stuart. It was my pleasure. I really enjoyed this today.
Thank you.